Hello and welcome to our session about Trimble Pivot Platform 4.3. I, the presenter, my name is Martin Janousek. I'm the product manager for Trimble Pivot Platform at Trimble. And so I'm located in the Trimble Terrasat office near Munich in Germany. That's where we actually develop this software, where we have the engineers and a lot of our support and QA teams. And what I want to introduce to you is our latest addition to the series of Trimble Pivot Platform and the previous software versions for network operators, GNSS network operators that deal with reference stations and want to provide corrections, mainly VRS corrections or in other formats for network RTK purposes. And actually, with this version, we are now 20 years in. It was 1999 when we released the first software solution, GPSnet, for VRS processing. Well, and it's not 1999, it's August 2019, and I want to talk about the highlights that we have in the latest release. I want to give you a little bit of background information, why we have done certain things, and mainly look at how they help you to improve the operation of your network, where it might make the network more precise, the solutions for the customers in the field more robust and more precise, and help you with dealing with the network. So, what this means is take a look at the new features and functionalities, understand what's behind that, and understand how you, as a network operator, benefit from this update and from the new features and functionalities. I give an overview about additional bug fixes that we have in the software and some updates on IT-related questions, like supported SQL versions. There are a few words on the release and update process. What does it mean to you? What do you have to do? And, well, we close with a summary. Okay. Let's get it on. First, before I talk about the software itself and the new version, I just want to give you a brief introduction on actually BeiDou, one of the satellite systems that we have in sky and that we typically use or can use if we are dealing with GNSS and real-time networks. And why am I talking specifically about BeiDou? You will see that in a few minutes when I come to the new functionality in Pivot 4.3, and to start with just a brief overview of what BeiDou is and where we are going. So BeiDou, the Chinese global navigation satellite system, actually consists of three separate systems, three satellite systems if we want to and we expect to have full constellation in 2020, which means next year. So that's the latest new satellite system. It's called BeiDou 3. There is a difference in the satellite signals, or the signals that are being that are available here on Earth from the satellites. So BeiDou 2, that consisted of the frequencies B1, B2, B3, and that is changing, or it has changed. So the new satellites, BeiDou-3, which become available in addition, have the frequency B1 and B3, just as BeiDou-2 had it, or has it. In addition, we have B1C and B2A frequencies, signals. And on the next slide here, we can see in the first graph on top of the screen, we can see where the frequency bands are. So what is called compass here, that's what I refer as BeiDou in my presentation. So you can see where the frequency bands are. And what is more interesting, below you can see BeiDou-2 in the second line, and the bottom line is BeiDou-3. And this is where we can see the various signals, and we see for BeiDou-3 that we have box signals, as it's being handled, for example, also by Galileo. And it provides far more robust signals, which is good for tracking. And what we can see here on the right side is an overview of what we can track, BeiDou-2, BeiDou-3, and then for each of the frequencies. And we can see what we can track with the NetR9 and with alloy receivers, Trimble NetR9, Trimble alloy reference receiver, the reference station hardware, because there are differences as well. So what we can track in BeiDou-2 in the current older satellite systems is B1, B2, B3, of course, and you can see that we can track B1, B2, B3 with the NetR9, and of course alloy. And we can see that we can track B1, B1C, B2A, and B3 in BeiDou-3 satellite system with alloy. We can't track B2, B1C, and B2A with the NetR9. B2, by the way, is not available within BeiDou-3. You can take a look at this graph, and it is, if you give it a while, then it's pretty easy to understand the differences. It might be confusing in the beginning because we have BeiDou-2, BeiDou-3, and then the different frequencies. But the more you deal with that, and the longer I will be talking about it, the more clear it becomes. So why are we actually talking about BeiDou? So we had, as I mentioned before, BeiDou-2 with, on a global scale, just a limited number of satellites. But if we look at this plot, the satellite tracking plot, which includes BeiDou-2 and BeiDou-3 satellites, and that is all what you can see here in yellow, you see that this adds a significant number of satellites in view. In the sky plot, satellite tracking plot, we have 24 hours of tracking in Munich in June this year, and we have a number of more than 10 satellites being available just from the BeiDou system. And actually, we want to track and we want to make use of as many satellites as possible. So BeiDou is adding a significant number. It helps us to get more robust solutions, more precise solutions. It helps the rovers in the field when they are operating under harsh conditions, let's say in urban canyons or in the forests. So we want to make use of those satellites. There's another overview of what we are dealing with. So if I just go back to this slide, we see that we actually have a total of 40 to 45 satellites in view, and we want to make use of those satellites. Here is another overview. And there are some other requirements about size and connections and connectivity. So all that concludes in new GNSS chips and new GNSS boards that are required in the hardware. On the software side, the challenge is similar. We have more satellite signals, we have more constellations, we have more frequencies, and we also have at the same time, so we have to deal with more signals, and we need to process them if we want to use them. And we also have more field users, which means we have more connections to the reference station network. We have more Rover users who request an individual VRS solution or a solution in one of the other formats for network RTK. So that requires a more advanced processing solution on the software side. Actually a more efficient way for handling all that processing load, because more users, more satellites mean additional processing load for the software and for the servers. So in order to deal with all those challenges, we need to provide updates and modernization paths. And the solution that we offer at Trimble is, for the hardware side, is the Trimble Alloy reference receiver. And on the software side, it is Trimble Pivot platform. And specifically, if we look at the processing part for network RTK corrections, it's the RTXNet processor, which is capable of dealing with all the constellations that are available up in the sky. All right, so that was the introduction. Let's look on what specifically is new in our August 2019 release of Trimble Pivot Platform version 4.3. And bam, we are back again talking about BeiDou 3. So what we have done about BeiDou 3 so far is that earlier this year, with a software update for the version 4.1, which was 4.13, we added BeiDou 3 tracking and storage. So again, BeiDou 3 is there, it's available, it will get more, we will see more satellites, but satellites are there already, and we should be using them. We need a solution to use them, because that is adding integrity and robustness for our solutions. So we added BeiDou 3 tracking and storage in T02 and Rhinex 304 formats. So if you have reference stations that can track BeiDou 3, you can see that tracking and you can store the data. At the same time, it was also possible to use the data in the ref data shop and for course download, which means, for example, Rhinex download, so that you could eventually analyze the data, check the data, share it with scientific organizations that want to get hands on BeiDou 3 data. What we're introducing now with 4.3, which is the next logical step if we want to deal with BeiDou 3, is that we give you a solution, functionality to stream corrections. So we are adding a real-time output, RTO single base corrections for BeiDou 3. So that is a single station RTO or multi-station RTO. And what you can output actually is a combination of either B1 and B2 or B1 and B3. So B2, if we look back at or think back of the chart that I had, B2 is actually from BeiDou 2, so that's kind of the old system, but we can utilize B1 from the new satellites as well. B1 and B3 is completely from the new satellite system, BeiDou 3. It's available with NetR9 and Trimble Alloy, so don't be scared that you would have to go to Alloy immediately. The NetR9s, if you have them, they do the job. But if we look at the frequencies that were or are available with BeiDou 3, we have B1C and B2A that is available with Alloy. And the logical path will be that also those signals will be used. However, today, B1 and B2 or B1 and B3. And if you wonder, okay, what should I offer to my customers? Which one of those combinations? Let the customers decide if they have rovers in the field that can deal with B3 from BeiDou 3. But you can offer both. So let the customers, the rover users, decide and test, do your own testing. You can provide both combinations on two separate parallel mount points. And you can output BeiDou 3 actually with CMRX or RTCM 3.2 multi-signal message. This is actually what it looks like. So on the left side, that's what we added earlier this year, tracking and storage. So you see that everything that is higher than C19, so we have C27 up to C33, those are BeiDou 3 satellites. Pivot can track it and make use of that and store the data. And what we are adding right now with Pivot 4.3 is that we can output correction data, as said before, either B1, B2, or B1 and B3, and you will find those property settings in the RTO module. What else is new? So BeiDou obviously is comes from China, and it has a certain focus to be used in China, but it is available globally. So BeiDou 3, the new edition, is of global interest because anywhere on the world you will get the chance to track a significant number of additional satellites. What is specific for China is that the Pivot UI becomes available in simplified Chinese. So you can get an idea of what it looks like on the right side. This will help our Chinese customers to operate the software. All the views, all the context menus, all the property settings are available in China. There are some terms which in the GNSS world are being still used in Latin letters, but it's most of the content is in Chinese, and it is pretty straightforward and simple to enable it. It just requires changing the Windows operating system language setting to simplified Chinese, and then automatically the Pivot UI is available in Chinese. Please note the help files are currently available in English only, but the UI, what network operators work with most of the time, that is available in Chinese now. Another new technical innovation that we have with Pivot 4.3 is RTX orbits and clocks bridging. And what does it mean? So what we are doing in Pivot is that we use Trimble RTX orbits and clocks information as the input source for the satellite orbits. So we need the orbit information within Trimble Pivot platform, and we want the orbits to be as precise as available because that helps us to do precise processing. to minimize the network downtime. We actually, if we look at the past 8 years, we wouldn't have any downtime in the RTXNet processor. Just to let you know, this is not an option or property setting. This is actually hard-coded to 60 minutes. But I give you some more details on what this means and what this looks like. So let's assume a setup that we have here with Pivot. Pivot would be here with the RTXNet processor, and we have an ephemeris manager. The RTXNet processor calculates the Yono and Chopo residuals. The ephemeris manager is handling the orbit information for the satellites. We have a reference station that is tracking the signals, and from the satellites, reference station satellites in sky, and the ephemeris manager is actually fed by the Trimble RTX orbits and clock information. So let's assume RTX is not available for whatever reason. In the past, for up to 2 minutes, everything worked fine, and then RTXNet processor stopped working, processing. And what we're changing here is that this will work for up to 60 minutes. Of course, we did some testing to prove to ourselves and to you that this actually has a big benefit and changes a lot. So what we can see here is that we artificially created 10-minute gaps. RTX orbits and clocks were not available for 10 minutes. Then it was available again for 10 minutes. So it changed on and off for 10 minutes. And in the upper graph, we see the kind of old solution where we have not had a 60 minutes bridging. And what we see here is the residual result for the GPS 31 satellite. So every 10 minutes we had a gap, actually. So the gap was for 8 minutes. We propagated 2 minutes, then we had 8 minutes. And what you can see here is then for 10 minutes, we again had RTX information, 2 more minutes propagation, and then 8 minutes gap. With the new solution, we don't see any gaps. So we see here a little shift twice, but that's just a visualization issue. Actually, in the software, everything keeps working. And what is even more important to know and to note and to prove is that it works on the rover side, because that is of the biggest interest, that the rovers in the field will continue working. So again, we have 10-minute gaps here. And what we see here in the graph is a simulated rover in the field getting corrections from a system where we have 10-minute gaps in respect to the RTX stream or the RTX input source. So in the upper case, you can see the rover in the field stopped working every 10 minutes or 12 minutes. What we see in the graph below is that even though we had those gaps, the rover in the field continuously worked and had a position and was fixed with no interruption. So in a summary, what this new functionality helps us, or enhanced functionality, is to provide the full network functionality, which means corrections for the rovers in the field for up to 1 hour, even if there should be the very rare or unexpected event of having no RTX data input. And this 1 hour gives us time. It gives us time to troubleshoot, either on the Trimble side, if there should be anything broken with the RTX stream, or also on your side, if there should be something with the communication to the RTX stream. So maybe there is, I don't know, suddenly the firewall is blocking a certain port. Or there is generally, you have everything with the LAN, internal communication, but you have the outbound communication over the internet and it's broken. So on both sides, wherever the issue might be, it gives us time to troubleshoot and to bring the system up and running again within those 60 minutes. Please note what will happen. What we cannot avoid is that you will lose some satellites over time. So new satellites cannot be fixed once they become available to track. And existing ones will be lost if there should be a loss of log. But this typically means that within those 60 minutes, let's assume you have 20 satellites that are being processed. And within those 60 minutes, you will lose a couple of them, maybe 4, 5, or 6. But that leaves us still enough satellites to serve the rovers in the field. And you might ask or want to ask if there will be any effect on the accuracy. No, there won't be, because the propagation for those 60 minutes is typically precise enough. The results from the residuals processing is precise enough to have very precise results for those 60 minutes. All right, what else is new? So we have, within Pivot, we have certain apps, add-on functionality. One of that is Trimble Online Processing, the top app. What it actually does is that as a rover user, a field user, I might do static observation, and that is maybe because I want to have a high precise position for a certain point, or my communication to the VRS server was down, so I just take some points and I want to have it processed against static data, against the reference stations. I can have a module within Pivot. Some of you certainly know it and utilize that. And with the top app, I can have a portal where customers upload their data. Data will be post-processed, and the customers receive a report with the post-processed results. And actually, as the final result, they get a position information. So we enhanced this functionality, which we released first time 5 years ago. We enhanced this 2 years ago with the automatic height addition, so that you can select a geoid. And there's a further addition to it, which makes it more complete, even more complete. So what we have added here for Pivot 4.3 is the option to enter or correct the rod height. And it's very straightforward. It's all within the web interface. Very simple. I show you a screenshot on the next slide. So rod height, if you know the rod height or the reference point that is in the RINEX file, is when you know it's wrong, you can correct it before the data will be processed. In addition, Trimble, the top app will use precise orbits if they are available. So the processing will be done with precise orbits. Practically, that means that precise orbits will be used if there is a 2 weeks time difference between when the data has been observed and when you ask for processing the data. In that case, precise orbits will be used, which leads to more precise results. And something that goes specifically back to a lot of requests from you. We have had a lot of requests about can we change the language? Can we do our own translation? Is there a file, a template that we can work with? So the reports, until now, they've been hard-coded, and now we are introducing customizer reports. There is a file which is the template for the report, and you can change that and you can customize that. So, and this is what it looks like. So looking at the rod height on the lower left corner, you can see that there is an option in the web interface, the top app web interface, to override the rod height from the file. Very simple. And this is what it looks like if you want to use the precise orbit. So there is a property setting where to store the precise orbits, and then if there is a job being done and processed within Pivot, it will indicate in the order history if precise orbits have been used. Well, and if precise orbits are not available for all satellites or for all the processing period, then it will also use the broadcast orbit, and it will indicate that in the report. All right, next is something that is not related to GNSS, not related to processing, not related to anything that happens in the sky or with the receiver, but it's still important. And again, this is something that has been requested many times because this gave you hard times typically with IT departments. So Pivot can be installed and can run under a non-admin Windows user. So until now, it always required an admin user, and the IT guys, they don't like it for good reasons. But now it can run under a non-admin user, and the user can be selected in the setup control. So when the software gets installed, and the benefits are very obvious for those of you specifically who have been fighting that in the past. So it is improved IT security. That is actually the reason why the IT departments request that, and you will have less conflicts with the IT departments if you can run it under a non-admin user. Okay, going back to something that is related to GNSS and tracking and the processing and modeling and doing corrections is what has the long name of manual selection for physical base station range. And I will also use the term tropobands. We don't have a catchy phrase for this functionality, but it has to do with tropobands, troposphere, vertical accuracy, and has to do with the selection of physical base station. So, talking about vertical accuracy is mainly influenced by the troposphere and the modeling of the troposcale. So what we have added is a functionality that allows you to exclude specific receivers from being a physical base station if you know that it might have a negative influence on the vertical accuracy for the rovers that are nearby. And I will show you a little bit more. I have some more slides and graphs that explain in more detail what we are doing here. This might be applicable and would be recommended to get applied typically in mountainous areas, but should be done case by case. So there is not a specific rule, or not. We cannot give specific guidelines with some thresholds where this should be applied. But this is an option that might be interesting for those of you who have reference stations on different elevations. And again, we take a look in the next slide. And it can also be used. That was not our original intention, but we figured out, hey, this helps other cases. It can be used where in case you have unreliable communication to reference stations. And maybe that's just temporarily. So if you have reference stations that constantly go on and off due to communication, you might want to exclude those stations from being a physical base station, because that will have negative impact on the rover performance. So this is, let's say, a second application for this, but let's look at the vertical accuracy first. So why would we actually want to exclude a reference station in some cases? So VRS and RTK positioning assumes that we have similar or almost identical troposphere and ionosphere conditions at the physical base station, at the reference station, and at the rover location. So that's also why we have limitations in the distances. If we do an RTK measurement, we typically talk about 20 kilometers, 15 miles. If we say VRS, we say, well, your reference stations should be in a distance of about 50 to 70 kilometers from each other, so that we still have a good modeling of the conditions. So we are assuming similar conditions. The VRS observations and also single base corrections are actually derived from a physical base station. So we have a relation to a physical base station between the physical base station and the rover. However, the troposphere can change significantly over small distances if we have a large vertical difference between the reference station and the rover in the field. And as stated before, the vertical component strongly depends on the troposphere estimation. So what if there is a significant difference between the physical base station and the rover in the troposphere, which typically means there is a significant difference in height? So let's look at this graph. What we see here is a setup of, let's say, a network. We see a subset of 3 reference stations. Two of them, the left one and the right one, they are at a lower elevation level, and we have one or more stations that are somewhere on top of the mountain, which makes sense because you have far better tracking situation. You see more satellites than if you are somewhere down in the valley. And in this case, if we had a rover in the field, the rover would typically get the corrections, the VRS corrections, the stream from the closest reference station, which in terms of distance is the station which is on top of the mountain. If we look at what I called before the tropo bands, we see that the reference station on top of the mountain is in a different tropo band than on the lower elevation. And tropo band means that we have similar troposphere conditions, similar troposcaling there. So in this case, we can imagine that we have certain factors, conditions in the yellow band, and we have completely other conditions in the blue band. In that case, and that influences the vertical accuracy on the rover side if we have a big difference between the rover and the reference stations. So in this case, we have a negative influence from the vertical distance between the rover and the physical base station. What we introduced with Pivot 4.3 is that there is an option in the RTO net properties that allow you to exclude stations, reference stations, from being a PBS. Pretty straightforward, pretty simple. It's just a few clicks and then a station won't be used anymore as a reference station. However, at the same time, it still remains valid for VRS processing. So the observations are still being used for the processing, modeling of the ionosphere and troposphere, where it actually is good that we have stations that are spread over the area and over the vertical component. So we look at this again. So we exclude actually the station at the on top of the mountain, unless there is rover or there are rovers that are working on top of the mountain. But in the typical case, you would have most rovers somewhere on the lower elevation. So you don't have the physical base station on top anymore. So the second next close reference station will be used, which is then one out of the same troposphere band, and this will help us to get a far better result on the rover side. So far the theory and explaining what we are doing and why, and just look at some testing. So we have a test set up in Germany and Austria, and there we have the Alps, so mountains. And what we see here is we have two rovers, simulated rovers on an elevation of 955 meters, and we have two reference stations which have almost the same distance, 50 kilometers to the red reference station and 45 kilometers to the blue one. So typically the blue one would act as the physical base station for the rover, and what we see here is that the red one is on a similar elevation, the blue one is on top of a mountain much higher. And this is the outcome. So we see 24 hours tracking and rover positioning results. And what we see here, the red one is using the physical base station that is further away, but on a similar elevation. And this is the height component, the vertical, and the accuracy is much better. We also see the standard deviation is a little bit better. There is not much of a difference, but we get much closer to the true result. So as a summary, what we have here is that you can select certain stations to be ignored as a physical base station. The observations still will be used. So it is different to completely exclude a station. We still have the benefit from the reference stations. So at the end of the day, we have an option or the possibility to actually improve the vertical accuracy on the rover side. And at the same time, this functionality can be used to avoid what I would call irritations from frequent, constant physical base station switches in case of bad communication. Okay, what else? So we have something about the ref data shop. Typically, if you have a network or you operate a network where you have a lot of requests for Rhinex downloads, those requests would typically get queued up, especially if you have large orders coming in asking for a lot of data. So one after the other would have been processed. And what we are adding here is that you can configure the number of CPU threads running in parallel. So this means that the jobs will be done much quicker. You don't have that queue. That will increase a little bit the CPU load, but the processing is done much faster and you get rid of the queue. We have something new about the code bias calibration. So the raw data analysis for the code bias calibration and the antenna calibration is being moved from the server to client. So far for the code bias calibration, which helps us to get more precise and more precise results in the RTXNet processor, and it helps us to get more satellites in the processing. It worked in a way that data was uploaded to a server, to a Trimble server, and all the data was processed on our side. So that processing will take place in Pivot, and then the results of the raw data analysis and antenna calibration will be uploaded to the CBC server. So this requires less data communication, and the antenna calibrations now can also handle individually calibrated antennas. That was not possible so far. This will have the effect that the CPU load for the raw data analysis will increase. So the raw data analysis requires CPU power, so the load will go up for large networks. You won't notice any change if we're talking about the 40-50 station network, but let's say it's a 200 station network, you will actually see an increase of CPU load. Find a solution. We also have a recommendation for a single server setup, again referring to the release notes for more details. And we also have updated the list of supported Windows versions and Microsoft SQL versions. You can also see them here. You can also see the details in the release notes. The release process itself. Your license has been updated already if you are under a valid protection plan. So if you are under valid maintenance, and actually we took July 31st, 2019 as the date. If you had a valid maintenance on July 31st, then you are entitled to have a license update and to install Pivot 4.3. End of August is actually the release date. So by the time when you can see this webinar, we have released in August 2019, and you find the download link to see the installation, to get the installation files in the release notes. In the information letter that informs about the release. As I mentioned before, I recommend strongly read the release notes prior to updating, and in any case of technical questions or any other question, you can contact us via this email address, this rtns_support@trimble.com. That will go to our technical experts in the support team, our support engineers. So in summary, what we've taken to create this latest release of Pivot is actually your input, your feedback, your requests. So we listen to what you give us back, and I encourage you to continue with that. Give us your feedback and share your experience. At the same time, what we are also doing is that we take the feedback from our own VRS service, NetOps team. We are dealing with large networks on several continents, and of course there is a lot of experience in that team, and we also listen to them because their input also helps you if we then implement some of their implement the requests. And we also have, of course, technology innovations that is something that we've done throughout the last 20 years. So whenever there is a new constellation available, new formats, when our research department has something new that we can present to you, that we can put into a solution and the software, then we take that. In this case, the big solution, the big innovation is actually BeiDou 3, which provides you with significantly more satellites. We have functionality enhancements for the top app, talking about the rod height that is configurable and reports that can be customized. We try to do something about the vertical accuracy. We can't do the magic and have vertical accuracy suddenly as good as horizontal accuracy, but we constantly improve or try to improve or give you tools to improve the vertical accuracy. Cybersecurity is a topic that we are dealing with, the non-admin user, and we certainly will look into this more in future. And in general, we can say that software engineering doesn't stop here, and Trimble Pivot platform engineering doesn't stop. There's always something new. We always have new input. We always have new innovations that we put into a version. So this is Trimble Pivot Platform 4.3, and there will be more. And I hope that this release helps you, that you will be installing it. I strongly recommend that you install it. And well, that's my closing remark. Have fun. Talk to you soon. See you somewhere at an event, or get in touch with you by email. Thank you. Bye-bye.